In this chapter, let us now look at factorials and then at binomial coefficients. So starting with how to calculate with factorials. So for example, 5 minus 3 factorial, we have to take first 5 minus 3 is 2 factorial. We get 2 times 1 is 2. 5 factorial minus 3 factorial now is something completely different, because 5 factorial, when we take it really, we get 120, 5 times 4 times 3 times 2 times 1, minus 3 factorial being 3 times 2 times 1 is 6, so we get 114, so quite something different. 17 factorial divided by 16 factorial, by the way, in German factorial is Fakultät. So 17 factorial, we can rewrite that using this recurrence definition of the factorial as 17 times 16 factorial divided by 16 factorial, and this is now obviously just 17 because the two 16 factorial cancel out. 10 factorial divided by 7 factorial, we can do very similarly. We expand the 10 factorial by writing it explicitly as 10 times 9 times 8 and now times 7 factorial, and the whole thing divided by the 7 factorial yields just 10 times 9 times 8, which is 720. 7 factorial plus 8 factorial divided by 9 doesn't look like you can do much about it, but well, let's have a look. 7 factorial, let's keep that, and the 8 factorial can be written as 8 times 7 factorial, and the whole thing divided by 9. I'll write for the 7 factorial 1 times 7 factorial. And now what you see, we get 1 plus 8 times 7 factorial divided by 9, just by factoring out the 7 factorial in the numerator. And 1 plus 8, well, that's obviously 9. So I can cancel it out with the 9 in the denominator, and I get as final result 7 factorial. Last, let's look at the following. 12 factorial divided by 9 factorial times 3 factorial. I can write that as 12 times 11 times 10 times 9 factorial. In that way, I can then cancel out with the 9 factorial in the denominator, and let me write the 3 factorial explicitly as 3 times 2 times 1. So we get 12 times 11 times 10 divided by 3 times 2 times 1. Now I can cancel out the 3 times 2 against the 12, 2 remains, and we see the final result is 220. Well, that's about factorials. Let's get to the binomial coefficient, something we haven't seen yet. So I'll introduce it right now. The binomial coefficient, written with this bracket and the n above the k, we read that as n choose k. In German, we would say n tief k. And on your calculator, you'll find it as NCR, n choose r. The n choose k just means n factorial divided by k factorial times n minus k factorial. Let's look at an example. So 10 choose 3. This means n is 10, so I get 10 factorial divided by k factorial. K is 3, so I have 3 factorial times, let me write it in brackets, n is 10 minus k being 3, so 10 minus 3 factorial. So we get 10 factorial divided by 3 factorial times 7 factorial. Let's do it explicitly again. 10 times 9 times 8 times 7 factorial divided by 3 times 2 times 1 times 7 factorial. The 7 factorial cancels out, so what remains is 10 times 9 times 8 divided by 3 times 2 times 1. Well, 3 cancels out against the 9, the 2 cancels out against the 8 here, so we get in the end 120. Please note, when you have to calculate by hand the binomial coefficient, that what remains here, the number of factors in the numerator is exactly the number of factors in the denominator when we use the 1 here. And obviously when we look at this, we'll use just the larger of the 2 factorials down here to cancel out with the numerator.
Let us now look at the most important properties of the binomial coefficient. Let us start with the first rule, n choose k. equals n choose n minus k. This becomes immediately clear when we look at a simple example. 12 choose 3 is by definition 12 factorial divided by 3 factorial times n factorial. Now let's rearrange the order of the denominator. We get 12 factorial divided by n factorial times 3 factorial, and this is obviously again 12 choose 9. So we've shown 12 choose 3 equals 12 choose 9, and that's exactly what this rule here in front says. The next rule just says that n choose 0 or n choose n are always 1. Again, we can calculate that now very simply, because n choose 0 is by definition n factorial divided by 0 factorial times the n factorial. And the n factorials cancel out, so what remains in the end is 1. We could do the same with n choose n, or just say, well, according to rule 1, it's obvious that it's the same. Last rule, n choose 1 is equal to n, and that's also the same for n choose n minus 1. Using the definition of the binomial coefficient, we get n choose 1 is n factorial divided by 1 factorial times n minus 1 factorial, and then in the next step, let's write n factorial as n times n minus 1 factorial using the recurrence definition. Copy the denominator, we can cancel out the n minus 1 factorial, and what remains is just n. In the next chapter, it will also become intuitively clear why these three rules are correct.